In this section, we're going to review solving quadratic equations by factoring. And in order to do so, we're going to use what's called the zero product property. And that is to say, if the product of two factors is 0, then at least one of the factors must be 0. Or in other words, if a times b is equal to 0, then either a equals 0 or b equals 0. Well, in example 1, we have an example where two factors, 4x plus 3 is 1 and 2x minus 1 is the other, are being multiplied, and the result is 0. So one of two things must be true. Either 4x plus 3, the first factor, is equal to 0, or 2x minus 1, the second factor, is equal to 0. Now we can solve each one of these. We can subtract 3 over here and then divide by 4, and we get x equals negative 3/4. And for the other equation, we can add 1 to both sides and then divide by 2. We get x equals 1/2. That gives us a solution set. Two solutions for this equation, negative 3/4 and 1/2. Whenever you have a quadratic equation, that is one in which there's a squared term when written in standard form, there will be two solutions. So we don't actually see the square in this equation, but if we look at the original equation here, if you had multiplied those two factors out, we would have gotten a leading term of 8x squared, that is 4x times 2x. So it is a quadratic equation. Let's take a look at another example. This one's already factored for us as well. And so we have one factor, negative 3m, and we have another factor, m plus 7. There's a times sign understood between them, and the factors multiply together to give you a result of 0. So that means either the first factor, negative 3 times m, is equal to 0, or the second factor, m plus 7, is equal to 0. Now let's be really careful about solving that first equation, negative 3 times m is equal to 0. Saying it out loud, negative 3 times m is equal to 0, so that we understand that you have to divide in order to find that result. And 0 divided by any number is 0 in simplified form. So make sure that you're giving your answer in fully simplified form, which is 0. Another way to look at this equation is we can just say negative 3 times what number is equal to 0, and that result is 0. All right, let's take a look at our other equation. We can subtract 7 here. We get m equal negative 7. So that gives us a solution set. Use those curly brackets for a solution set of negative 7, 0 are our two solutions. You can list them in either order. I'm going to list them from least to greatest, but you can list them in either order. All right, try the first example below here. Try solving that equation and pause the video while you do this. All right, here's the result. If the two factors multiply together to give a result of 0, that means that one of the two factors is equal to 0. So we set them both to equal 0, solve for C, and we have two solutions. All right, try this one on your own and pause the video while you do this one. All right, here's the solution set for this one. You might find yourself skipping steps, doing some of the simpler solving of the equation in your head, and that's fine. It's important to know that when you have this type of equation, it's not just good enough to find one solution. When we say solve, that means find all solutions. All right, let's take a look at some examples that are a little bit different. The next couple of examples will have equations where the polynomial is not factored. So we're going to factor the polynomial first and then use the zero product property to find the solution set. So in example 2a, we have negative 5x squared plus 3x is equal to 0. Notice that that's a type where we can factor out a GCF, a greatest common factor. So since the first term has a negative coefficient, that is the highest exponent term has a negative coefficient, I'm going to factor out a negative GCF. So factor out negative x, that'll leave us with positive 5x minus 3 equal to 0. So now that we have this in factored form, either negative x is equal to 0 or 5x minus 3 is equal to 0. So if the opposite of x is equal to 0, we can divide by -1, and that's going to give us x equal to 0. 0 is its own opposite. And then for the other equation, if we add 3 and then divide by 5, that's going to give us an x value of 3/5. I'm going to put my final answer in solution set form, 0, 3/5, curly brackets when we use a solution set. When you use regular parentheses, that means an ordered pair, which means a point on a graph. All right, let's try another one here. This one's a trinomial set equal to 0. So we're going to try factoring this one as well. This is going to involve the AC method here. A times C is 2 times -9, which is -18. Let's just list some factors of -18. 1 and -18, 2 and -9. And what you'll notice about 2 and -9 is these guys add up to -7. So that's the opposite of what we want, because we want them to add up to +7. So let's just reverse the signs on them, -2 and 9. All right, now let's use a box to do some factoring here. And we're going to put the first term 2u squared in the upper left box, -2u next to it, 9u below it, and then the last term -9 in the lower right box. The GCF of the top row is 2u, the GCF of the bottom row is 9, and 2u times u is 2u squared. 2u times -1 is -2u. We can check the rest of the products, but that gives us 2u plus 9 times u minus 1 is equal to 0. And then we can set each of those factors equal to 0. And that's going to give us u is equal to -9/2, or u is equal to 1. So there's our solution set for this equation. And we've got a couple of try these on the next page here. All right, try A below. Pause the video while you do this. Here's the solution set for this quadratic equation. And now try B on your own. Pause the video again while you do this. Here's the solution set. This one was a trinomial, so it required factoring using the AC method. All right, let's take a look at some examples where they're not written in standard form. So we'll have to do more than just factor. So some guidelines here. We will remove any parentheses using the distributive property, unless it's already factored for you and the other side of the equation is equal to 0. Clear any fractional coefficients. We're not going to encounter that, so I'm going to cross that out. But what we do want to do is we want to move all terms to one side of the equation. That is to say, the other side should be 0. And then arrange the terms in descending powers. And after you do that, factor. Then use the zero product property to solve for the variable. A quick note, the exponent on the variable of the leading term of the polynomial when written in standard form indicates the number of solutions. So if you see the highest exponent on the variable is 2, that means we're going to have 2 solutions. All right, let's check out number 3. I want to show you a common mistake that students make on this one. This seems easier than it is. Sometimes students will divide by x, and then they get 5x is equal to 3, and they solve, and they only get one solution. Remember, this is a quadratic equation. If we divide by that variable, we have the potential to lose a solution. So what we want to do here is we want to move all the terms to one side. That is to say, we're going to subtract 3x from both sides. Then factor, and this we can factor out the GCF. X times 5x minus 3 is equal to 0. And then we can use the zero product property to write x equals 0 or 5x minus 3 is equal to 0. This one's already solved. Add 3, divide by 5, that gives us 3/5. So we do have 2 solutions, 0 and 3/5. All right, let's check out another example. 6n squared plus 6 is equal to 11n plus 2. We do not have a 0 on one side of the equation. That's one thing that's very important. So if we subtract off the 11n, I'm going to write it next to the 6n squared right after it because it's the next term since it has an exponent of 1. And then I've got a plus 6 and subtract 2 to move that other 2 to the other side, right? We moved the 11n plus 2, and so when moved to the other side, those terms became negative. Now we can combine our like terms. 6n squared minus 11n plus 4 is equal to 0. Now let's factor that. A times c is positive 24. So when we're looking to split the middle term, we're going to look for two factors of positive 24 that add up to negative 11. Well, factors of a positive number can either be both positive or both negative. And negative 8 and negative 3 will work nicely to add up to negative 11. GCF of the top row is 3n, of the bottom row is negative 4, and then 2n on the top left, and minus 1 on the top right. So our two factors are 3n minus 4 and 2n minus 1. So either 3n minus 4 equals 0 or 2n minus 1 is equal to 0. Add 4, divide by 3, that gives us 4/3. Add 1 and divide by 2, and that gives us n equals 1/2. So I'm going to write these in order. 1/2 is the smaller of the two fractions. So I'm going to write that one first. You can write them in any order that you wish. All right, now a couple for you to try. So try A below on your own and pause the video while you do this. All right, we should have gotten two solutions, 0 and 1/7. All right, now let's try B. Pause the video while you do this one. All right, two solutions here, negative 3 and positive 2. All right, let's take a look at one last variation. These, it might be tempting to just go ahead and use the zero product property, but we can't use the zero product property because the right side of the equation here is not 0. You can only know that one of the factors must be 0 if the product is 0. So we're going to have to do more for this one. We're going to have to remove the parentheses by distributing or multiplying y times 10 minus 3y. And then we're going to move the terms around. Oops, on the right side that was 8. We're going to move the terms around, and I would encourage you to move the terms to the side where the squared term has a positive coefficient. So we can add 3y squared to both sides and subtract 10y, and then make sure that you've got those terms in descending powers. So the 3y squared term comes first, then the y term, and then lastly the term with no variables. Now that we've got it in standard form, we can factor 3y squared, 8, and we can just split the middle term. 3 times 8 is 24. Factors that add up to negative 10 are negative 6 and negative 4. So we'll split the middle term accordingly. That gives us a y and a negative 2, 3y and negative 4. So our factors are y minus 2 and 3y minus 4. So either y minus 2 equals 0 or 3y minus 4 is equal to 0. Adding 2 and adding 4 and then dividing by 3, we get 4/3. So in order, our solutions are 4/3 and 2. All right, one more example of this type. In B, we have w plus 4 times w plus 5 equals 30. Again, notice that the product here is not equal to 0, so we're going to have to multiply this out and move some terms around in order to get it in that form. So this time we're multiplying, not factoring, so w plus 4 times w plus 5. We know the factors, and we need the product. So this is w squared plus 9w plus 20. We got the 9w from combining those like terms, equals 30. Now we have w squared plus 9w, and then we're going to subtract off 30. That gives us minus 10 equals 0. Now let's work on factoring that, since we have it equal to 0 now. So w squared minus 10. Factors of negative 10 that add up to positive 9 are positive 10 and negative 1. So we'll split the middle term using those coefficients. So GCF of the top row is w, of the bottom row is negative 1, w on the top left, and 10 on the top right. So our factors are w minus 1 times w plus 10. And that gives us two solutions, negative 10 and 0. All right, now a couple for you to try. You can pause the video while you do A, Vila. Incidentally, let's make sure that these are the same variable. That should be x times 1 minus 2x equals 6. Now try. Sorry, one more change. Let's change this to a plus. So we have x times 1 plus 2x equals 6. All right, now pause the video and try this. Sorry for the typos in the question. This one should have two solutions, negative 2 and 3/2. All right, one more for you to try on your own. So you can pause the video while you do this one. C plus 2 times C plus 5 is equal to 4. All right, this last one had two solutions, negative 6 and negative 1. And that's it for this section.